atmospheric refraction. Let us see the atmospheric refractions here. So, see, star. What is our atmospheric refraction? Atmospheric refraction is due to the gradual change in the refractive index of atmosphere. We know that it is a refractive index has been studied by N or neta. So atmospheric refraction happens because of the refractive index of an atmosphere. So see, the refractive index of atmosphere gradually increases towards the surface of the earth because the hot air above is less dense than come to the cool air below. So what is happening here? This refractive index will try to bend towards the refractive index of the atmosphere gradually increases here. This refractive index is going to increase. Why it is going to increase? Because the Earth's surface, what's actually happening? So, I'll try to explain here clearly. Refractive index neta, it is increasing. Well, what is it? How it is increasing? It is increasing towards the Earth's surface. If this is my Earth, it is increasing towards the Earth's surface. Why it is increasing towards the Earth? Because the hot air in the atmosphere, there's a hot air. That hot air is less denser. Hot air will be less denser, right? It will be anyway. It's hot air, so or there will be all the particles inside that air will become scattered, and it becomes less denser. The hot air will be less denser, whereas the cool air will be more denser. So that's why, because the Earth has got a cool air which is more denser than the hot air which is present in the air, in the atmosphere. Because of that reason, the refractive index will increase, and that increase how? That increase towards the Earth. So because of this reason, the light gradually bend towards the normal. Why? Because of this, what will happen? The light will bend towards the normal. So now listen carefully. So the real position of star is different from its apparent position. So see, if this is the real position of the star, and this is called as an apparent position. If the star is over here, if we look at the star, actually the star, whatever we are seeing in the sky, that is not that's not the real position. That is called as an apparent position. But the real position will be somewhere else. So when it happens? Because of increasing of the refractive index of the atmosphere. So atmospheric refraction happens because of what, increasing of the refractive index of atmosphere, and that increases towards the Earth's surface. I hope it's clear to you. Then see, this is what we are talking about. If a person is standing over here, this is the star here, actually position. This is called the real position, and this is the apparent position. If a person is standing over here, he thinks the star is over here. It's an apparent position, but actually the real position will be, this is a real position. And why does this atmospheric refraction is taking place? It's mainly happening because of the refractive index. What is happening with the refractive index? The refractive index is increasing. Refractive index of what? Refractive index of atmosphere is increasing. How it is increasing? It is increasing gradually towards the Earth's surface. Why does the refractive index of atmosphere has to increase towards the Earth's surface? Because the hot air in the atmosphere is less denser than the cool air, which is more denser in the Earth. So because of that reason, the refractive index of the atmosphere will bend, it will increase towards the Earth. And because of that one, we can have this kind of phenomenon which is called as a atmospheric refraction. And now see the twinkling of stars. Now let us see what is twinkling of stars. The twinkling of stars is mainly because of, this is one of the applications of atmospheric refraction. The twinkling of stars is mainly because of the atmospheric refraction of starlight, and due to the changing of the position of the star. Why do the twinkling of stars takes place? The twinkling of star happens because of atmospheric refraction. What happens in the atmospheric refraction? This twinkling of stars happens due to atmospheric refraction of a starlight. And also the second reason is what? The second reason is that the star is not going to stay in one position. It is because of the changing in the position of the star, and also because of movement of the layers of the atmosphere. So see, listen here now. The twinkling of the star takes place because of three reasons. The first reason is what? It is mainly due to atmospheric refraction of star. The first point is atmospheric refraction of starlight. Then second one, what is the second point? The second reason is because of changing of the star position. Because of the changing of the star position. Then what is the third point? The third point is because of movement of layer, movement of layers of atmosphere. These are the three main reasons for the twinkling of star. So keep this in mind. First one is a atmospheric refraction of the starlight. Second one is changing of star position. Third one is movement of layers of atmosphere. So the light of the star sometimes brighter. Because of this reason, the star is sometimes brighter and sometimes not that so brighter. So because of these two reasons, we can say the star is twinkling. Because of these three reasons, sometimes the star will be brighter and sometimes it will be fainter. Fainter means it will be not much brighter. And this brighter and fainter reasons of the star will make us to appear as if the star is twinkling. So see, the planets are closer to the Earth than the stars, and the light from the star is considered as point source of light, and the light from the planets are considered as an extended source of the light. And so the light from the planets nullify the twinkling effect. So this is how we talk about the how the twinkling effect has been nullified. The planets, we know that the planets are closer to the Earth than the stars. Stars are very high in the space, very far distance, and the light from the stars are considered as a point source. Means it is taken as a one particular default source point, and again the light from the planets are considered as an extended source of light. These point source of light and extended source of light will make the planets to nullify the twinkling effect of a star. So see here in the next diagram, this same diagram we'll be seeing here. This is how the twinkling of the star takes place. Light from a star, it looks like this, it is changing, and ultimately when it comes over here, it looks like as the star is twinkling. The Earth's atmosphere with the moving pockets of the cold and warm air will make us to look like the star is twinkling. That's what I'm talking about. Because of the third point, movement of the layers of atmosphere. That's also one reason for the twinkling of the light. Now the second one we are talking here is about, let us see now. We will be talking here the advanced sunrise and the delay sunsets. The sun is visible to us about 2 minutes before the sunrise and about 2 minutes after the sunset due to the atmospheric refraction. Because of this atmospheric refraction, the sun is visible to any human being only for 2 minutes after the sunrise and before the sunset. Or so we can say that it is before the sunrise and after the sunset. Then the apparent flattening of the sun's disk at the sunrise and at the sunset is also mainly the flattening of the disk. Means we are talking about how the sun is moving its positions. That apparent position is also mainly because of the atmospheric refraction only. It is also because of the atmospheric refraction.